Hello and welcome to your Be Avalanche Aware presentation. This is a decision-making framework called Be Avalanche Aware. It was developed to try and mitigate the impact human factors has on decision-making in avalanche terrain. Here's the fundamental considerations of the decision-making process. They include weather and conditions, you and your party, and the mountain landscape. The most important phase of the process is the planning phase. If you create a plan that avoids avalanche hazard, then the other phases of the process are simpler. During the journey phase, your observations are simply confirming that the plan is still valid. With a well-formed plan, you should identify key places. This will be a location that is in an avalanche critical decision point where you're considering slope scale terrain choices. This routine creates an opportunity to reassess your situation and make the best possible decision. In the following sections, we'll look in turn at the fundamental considerations in the planning, journey, and key place phases. At the planning phase, we need to consider the weather and conditions. Two key forecasts are available from the Mountain Weather Information Service and the Met Office. These are important because they each have regional mountain-specific forecasts created by forecasters rather than raw data from models. Weather influences the avalanche hazard. Therefore, precipitation, wind speed and direction, plus the freezing level are critical pieces of information. By comparing several sources, you'll also gain an idea of the consistency between models and thus confidence in the forecasts. Here's a little information on how weather influences avalanche hazard. These symbols represent typical avalanche problems created by specific weather. We'll look at two situations that we often get here in the UK. This symbol represents wind-drifted snow. When the wind is above 15 miles an hour, drifting snow accumulates on sheltered lee slopes. Where it accumulates, we get the formation of wind slabs that can result in wind slab avalanches. It doesn't need to be snowing for wind slab formation, we just need snow that can be blown around. The location of this type of hazard is predictable, with wind speed and direction and the freezing level being key. This symbol represents a wet snow avalanche problem. This occurs when snow thaws and liquid water causes weakening of the snowpack layers. This will affect any existing snowpack above the freezing level. However, snow that hasn't been thawed previously, or areas that already have weaknesses in them, such as wind slabs, will be particularly sensitive. Although rain and additional loading isn't required for instability, rain will rapidly elevate the likelihood of avalanches. These avalanches will be described as wet slab avalanches or loose snow avalanches. Understanding this connection between weather and avalanche hazard helps you interpret the avalanche forecasts and the implications of your observations on the journey. Have a look at this forecast. What avalanche problem might you expect to develop, and where on the map would you expect it to occur? Wind direction is from the northwest, 40 to 50, gusting 70 miles an hour. So well in excess of that is required to blow snow around. Sheltered lee slopes are where the snow will accumulate as wind slab, so in this case southeast facing slopes. The freezing level is 550 metres, so wet snow will fall to about 200 metres below this. The upper limit of the accumulations will be where it becomes sheltered enough, so somewhere down below the windy ridgeline and summit. When we're considering conditions, the most important information is the avalanche hazard forecast. This is the Scottish Avalanche Information Service website, which contains a lot of useful information as well as the forecasts themselves. In each of these areas, observers or forecasters journey on the hill every day. They collect information on weather and its effect on snow distribution and stability. On the home page, there's a map showing the location of each forecast area with an indication of the hazard level. If we follow a link to the regional forecast, we can see the information that should be referred to daily. Here, there's a weekly snowpack summary and access to the last 7 days forecast. Hitting the Observe tab will provide information collected from the mountain on the day of the forecast issue. This is broken down into weather, snow stability and avalanche hazard, and mountain conditions. The snow stability and avalanche hazard observations are the most important information here. This will describe what the avalanche problem is, the aspect and altitude it's located, and any terrain features particularly affected. For example, corrie rims, scarp slopes, ridge flanks and gullies. Beyond this, there will be a description of locations with better stability and an avalanche hazard level, in this example, moderate. If we click on the Forecast tab, we'll see a similar format. The main section of the forecast is the snow stability and avalanche hazard forecast. This describes the predicted location of any hazard. This will again describe what the stability problem is, what altitude and aspect it will be located on, and the unfavourable terrain features most affected. The section will conclude with an avalanche hazard level. There's also a section outlining the weather forecast. This allows you to assess what the weather hazard is dependent on, which helps us focus observations on the journey. Further down the page is the avalanche problems. The icons will identify the avalanche problem, in this case wind transportation of snow and the formation of wind slab. Clicking on the icon will reveal whether the stability trend is constant, increasing or decreasing. Once we understand the avalanche hazard, we're ready to start forming a plan. Have a look at this forecast. Identify the avalanche hazard level, the avalanche problem and its location. Using this, we can identify the most likely hazardous area on the map. The weather influences are that the precipitation will be snow, with the freezing level 800 metres and strong wind from the south. The forecast is therefore describing where snow will accumulate as wind slab, and this will be on northwest to northeast aspects above 800 metres. So here we can see the most likely accumulation zone. The arrow shows the wind direction and is located on the windward and therefore scoured slopes. But what about the northwest and northeast slopes? These are now highlighted as well. However, we are currently considering weather and conditions in isolation. We also need to consider the mountain landscape or terrain. If we do, we'll notice that most, but not all, of the northwest and northeast slopes highlighted are in fact not steep enough to avalanche. We'll look at this in more detail in the mountain landscape section later. In the next section, we'll look at you and your party at the planning phase. Potentially, the most important aspect of experience is being able to create a realistic plan for the day. Experience helps us build a keen eye for detail when considering forecasts and the physical reality of a particular journey, ski or climb. Do you enough food and drink, spare layers, first aid kit and group shelter? Proper use and good functioning of all your equipment means that there should be no distractions that could interfere with your situational awareness. This brings us on to another aspect of human factors, decision making. Regardless of experience and good route planning, we are all subject to human error. 90% of avalanche victims trigger their own avalanche. From this point of view, it's worth considering avalanche hazard as a human problem, particularly when we consider that often victims recognise or feel that the situation is risky before being avalanched. Therefore, being avalanched is often a result of a poor decision rather than a lack of knowledge. Our decision-making processes are complicated but happen naturally and largely unnoticed. Because of this, we're vulnerable to what we call cognitive errors. There's many ways this can happen, but only a small subset can be identified specifically to avalanche situations. Fast, automatic processes that are good for everyday decisions can result in errors that in the mountains can result in avalanche incidents. These have been called heuristic traps. Although we know that decision errors are the cause of many avalanches, we haven't identified all the potential ways errors can happen or what to do about it. This is the reason that we have decision-making frameworks to help us avoid these errors. We'll use this knowledge to suggest some practices that will help you avoid becoming a victim of your own brain. So how do we use this knowledge? When groups are involved in decision making, it can result in less errors. If there's a leader, then any planning should consider the entire group, their skills and experience and personal ambitions for the journey. From this point of view, it's preferable that a leader promotes open communication by involving the group in any planning. The aim of this would be to form a team that is well informed with a plan that matched the experience, skills and ambitions of the group, and that every individual is compatible. In this way, expectations for how the group and individuals should operate can be established. What could be the possible causes of this situation? And what are the possible implications? Clearly, there's been a breakdown in communication. There could be many causes. The individual might not know where they are and therefore not realise that they are, in fact, at the planned crag. If they don't know where they are, they can't relate their observations to the plan. Otherwise, the individual might be distracted, not present or not updated during the planning phase. If there was an informal leader, then they haven't included the individual in the decision making, checked for understanding, engagement or buy-in from the whole group. The implications for this are numerous. The activity could be inappropriate for the individual on a purely physical basis. In terms of avalanche awareness, it's also possible that the plan has not been validated on the journey. Discussions should occur throughout the journey, structured around weather and conditions, you and your party, and mountain landscape. This couldn't have happened in this situation, as not everyone was aware of the plan or do not know where they are. The other possibility is that the individual is making decisions without consulting the group. These decisions may or may not be well informed. The start of this process is during the planning. Having considered weather and conditions, you and your party will do the same for mountain landscape in the next section. In this picture, you can see potential avalanche start zones, avalanche paths or tracks, and run-out zones. This therefore represents avalanche terrain, based on slope angle. Avalanches generally start on slopes between 25 and 45 degrees, with an optimum about 38 degrees. Once triggered, avalanches run down tracks. Angles here will be at least between 15 and 25 degrees. But there could be all sorts of variations such as small crags, cliffs or terraces. Eventually the avalanche will slow and stop on angles between 15 degrees and flat. These are of course average ranges. The size of the avalanche and the nature of the snow and ground it runs over will dictate what angles an avalanche will start on and how far it will run. This makes judging how far an avalanche will run tricky. We need to be able to identify avalanche terrain on maps. Slope angles can be measured using a ruler or purpose-built tools like this card. When using an OS 1 to 50,000 map like this, the thicker index contours represent 50-metre intervals. As a rough rule of thumb, where you see an area of steep ground that is beginning to lose a single 10-metre contour, the terrain will be at least 30 degrees. When there's more than one contour missing, you'll know it's well above 30 degrees. These slopes will be potential start zones, therefore terrain below will be potential tracks and run-out zones. Of course, whether the terrain actually has the potential to produce avalanches on any given day is dependent on the weather and conditions. Slope aspect is an essential consideration here. This will allow you to differentiate between steep slopes identified as hazardous in the avalanche forecast versus steep slopes that don't have any avalanche hazard. On a UK map like this, you will always be able to identify slope aspect using north as a reference. North is always the top edge of the map. For example, this slope is facing the right edge of the map, therefore is east facing. This slope facing the bottom of the map, therefore is south facing, and this southwest facing. Altitude is easily worked out by using the altitude numbers from spot heights or contours. We can therefore use the avalanche forecast to differentiate between hazardous and non-hazardous avalanche terrain. Look at this avalanche forecast and we'll use this to complete a plan. The avalanche hazard is moderate, the problem being wind-drifted snow and therefore wind slabs. These are forecast to be on the steepest, most sheltered locations on north to east aspects above 950 metres. There's also a cornice problem and the stability trend for both is constant. Here's the map with the route marked with intention to return the same way. Where in the map would you place the relevant avalanche hazard? Where would you have a key place and why? According to the forecast, the relevant avalanche hazard for this route is now highlighted. The start zones are likely to be well above our route and relatively small. This might mean that the run-out zones will be relatively small or short. Observations on the journey would best be focused on wind speed and direction, precipitation and temperature in order to identify whether the light snow showers have resulted in new accumulations forecast. We do get to slopes steeper than 30 degrees on this section of the route. However, it's mostly below 900 metres. Nevertheless, this section requires caution, thus it would be prudent to have a key place before committing. A key place could be at the location marked on the map here. This is before we are exposed to avalanche terrain and will allow us to reassess our progress and situation, working through weather and conditions, you and your party and mountain landscape. Hopefully, by the time you get to this location, you will have already have a good measure of the snow distribution and quantity, the avalanche hazard, and how well it matches the forecast. This would mean you're in a better position to make an informed decision on whether to continue. Visibility will play a big role on your certainty or otherwise here. In poor visibility, terrain decisions become complex, and at this key place, the best option would probably be to return to the car park. The view from the key place looks like this. In the next section, we'll look at how we continue the BA process on the journey. Once we're on our planned journey, hopefully most of the hard work has been done. This gives us a focus to our observations on the journey, following our fundamental considerations of weather and conditions, you and your party, and mountain landscape. From our planning, we will have identified what key weather and conditions variables to focus on. In this way, if we recognise that there is a difference in the weather expected, we can start thinking about what the impact might be on the avalanche hazard. However, you need to be aware of local variations, which can deposit snow in unexpected locations. If the visibility is poor, you'll have to use local information like boulders and short steep banks to assess the wind direction. Have a look at these photos and forecast. Which photo represents observations likely with that forecast? The weather and avalanche forecast predict a wet snow instability and associated cornice instability problem. The top photo shows frozen ground in the foreground and drifting snow from the ridge in the distance. This would be associated with a wind slab problem. Therefore, the bottom photo is the correct one. In the lower photo, you can see that the cliffs are looking relatively black. This indicates that any snow on them has thawed. Also, if you look at the slopes below the cliffs, you can see what are called roller balls or sun wheels. These are caused by moist snow forming snowballs that run downhill and are started by thawing snow or rocks dropping off the cliffs above. You can also see debris from cornice collapse due to thaw. This has slid down a track to stop in a run-out zone. These observations given the forecast would therefore confirm the validity of your plan. Let's now consider you and your party observations. It's important to continue what was started at the planning phase, framing the communication and observation agenda for the day and fostering a safe environment for individuals to have a voice. If the group is aware of the plan, important weather and conditions observations and alternative routes, it helps create a shared sense of purpose. This will help create a pool of individual observations and perceptions on which to evaluate the current situation. The intention is to create an uninhibited flow of information throughout a journey. Consider these groups. If you were to join them, what human factors would impact you? This will obviously have a personal element to it. However, for the skiing situation, the group size will need managing on many counts. If there's a spread of fitness, ability and experience within the group, then it will be harder to maintain open conversations and expressions of concern. You might get frustrated by having to stop and start constantly. This might make it difficult to manage clothing being too hot or too cold. These things can distract you from your enjoyment of the skiing and your awareness of the avalanche situation. You might find it easier to stay quiet rather than speaking up. A clear leader would help here, as the bigger the group, the harder the communication becomes. In the photo to the right, the group are in steep and icy terrain. They're well equipped with crampons, ice axe and helmets. Beyond that, it will require a familiarity with the equipment and good movement and route finding skills. In steep terrain, there'll be many decisions being made on route choice, and it's important to consider not just the consequences in terms of technical difficulty, but also of avalanche hazard. To maintain situational awareness, then individuals will need to be comfortable with the technicalities of the terrain and not become task focused. For both groups, if this was a first experience, it could be a very challenging day and avalanche awareness could suffer. This is another reason for fostering a safe environment for an individual concerns to be expressed. For mountain landscape observations, you've probably realised that map reading skills are essential, as you need to be aware of your location relative to avalanche terrain and avalanche hazard. You'll need to be able to identify avalanche terrain on the map and relate it to the landscape you can see. Can you identify hazardous slopes from the forecast on the map and in the photo? To help, Your position is marked on the map by a circle, and the map is orientated to the point of view of the photo. The slopes identified in the forecast are highlighted on the map now. This is a northwest to northerly facing slope above 1,000 metres. On your journey, the skill is to relate that to what you can see. These are the same slopes highlighted on the photograph. If you've done your job, by the time you get to a key place, you'll have a very good idea of the validity of the plan and what you'll do at your key place. Despite a situation where everything's going to plan, you should still stop and go through a key place routine. This is potentially the last opportunity to review the situation and update your observations. This might highlight something missed or something that has actually changed from earlier. Let's now consider you and your party at key places. This is potentially when you're under more pressure due to conditions or group dynamics. This can have a powerful influence on your decision making. This and other cognitive biases and heuristic traps are reasons to pay particular attention to the mental side of human factors. The key place therefore provides an opportunity to remove distractions and create a formal pause and check and challenge. Let's look at this situation. The key place is identified on the map. This is before you expose yourself to avalanche terrain, and visibility permitting will allow you to make slope scale terrain choices that you couldn't at the planning stage. You've planned to go climbing in this quarry and have identified this route in and a key place. You plan to climb on the coloured northeast facing buttress as it avoids the avalanche hazard. The forecast is for developing wind slab instability on the aspects shown in the compass rose, and the weather and conditions on the journey have been as forecast. You are at your key place marked on the map, and you can see the buttress in the photo. This is a northwest facing buttress that is marked red on the map here. While considering you and your party, what human factors do you want to address? What could be the implications of other groups? It is tempting to use other groups as an indicator of safety. If that group is getting up that slope okay, then it must be safe. This isn't necessarily the case due to spatial variation and the mechanics of how avalanches are triggered. It's entirely possible that another group will safely navigate an avalanche-prone slope because they fortuitously missed any sensitive trigger points. However, if you were to ascend the same slope and find a sensitive spot, you could trigger an avalanche which could cause the entire slope to slide. In addition, consider the forecast and your other observations. If the weather and conditions have been as forecast, then there's no reason to believe that the avalanche hazard will be any different from the forecast. Although the debris isn't obvious in the photo, if it was recent, then it's a clear indication of instability and a reason to avoid the slope. Although the key place in this situation is in a safe area before entering avalanche terrain, it's worth being aware of other people or groups and consider if they constitute a hazard through triggering an avalanche. At the end of the journey, it's worthwhile reviewing your day. The purpose of this is to use any learning for future trips. Even if it's gone well, there's often elements of the day that wasn't quite as expected. It could be that it was a lot less snowy than you expected given the forecast, or the opposite. Can you identify why? What was the biggest challenge of the day? Go back to the Avalanche forecast and blogs for the day and review them with an experienced eye. Have a look at the observations from that day. Does it all add up? Is there any useful comments on the blog? Also, with time, reflect on how you felt at the key places. Can you now identify any emotions, impulses or decisions that weren't so obvious at the time? If so, it's worth taking special note of this. We are all influenced by cognitive biases, and you might have just identified one of yours.